A shortcut to long division is called synthetic division. Synthetic division is normally used when our divisor has a leading coefficient of 1. As we look in example 1, we have x squared plus 2x plus 8 being divided by x plus 2. In synthetic division, we're going to draw a box, and we're going to take the constant term of the divisor and change its sign. So we're going to put -2 in that box. And then we're going to take the coefficients of the dividend and place them outside of the box, remembering to place a 1 if there is not a number there, and then our 6 and then our 8. We draw a line, leaving a space between the dividend's coefficients and the line. We're going to first bring down the first number. We're going to multiply the number in the box to the number below the line and bring it to the next position on our line. We're going to add 6 minus 2. In this case, we're subtracting. And then we're going to do the same thing. -2 times 4 gives us -8. And we're going to add together, and this will give us 0. Now, what does this mean to us? Well, the last number is the remainder. The next term is our constant term, and then we start our linear term placing a positive since this number is positive. And then if we were to have any more, we have our quadratic, our x squared, our cubic, x to the third, quartic, x to the fourth, so on and so forth until we run out of terms. So what this says is we have x plus 4 as our answer. So if I take x squared plus 6x plus 8 and divide it by x plus 2 using long division, I would end up with the answer x plus 4. And that's our answer. Remembering, since our remainder is 0, x plus 2 then is a factor of this trinomial. So let's go ahead and take a look at another example that is a little more complicated, for the simple fact that it's going to be a cubic being divided by a linear term. So let's take x plus 4 and divide it into x to the third plus 3x squared minus 6x minus 7. Notice I've written it differently, but we still have a division problem. This one is in fractional form, this one is simply in division form. We're going to again take the divisor and take the opposite of our constant term. Remember, the constant term has no variables. And we're going to take the coefficients of our dividend. So we have 1, 3, -6, -7. Drawing a line, we're bringing down our first number. We're going to multiply. -4 times 1 gives us -4. We're going to add down. So we have -1. -4 times -1 gives us 4. -6 plus 4, -2. -4 times -2 is 8. -7 plus 8 gives us 1. So in this, as in the last example, our last term is our remainder. We have our constant term, our linear term. Since there's already a minus sign, we don't need to put the plus sign, as well in the second one. Now we have an extra term. This is going to be our x squared. So our final answer is going to look like x squared minus x minus 2 remainder 1. Notice, since we have a remainder, x plus 4 is not a factor of x to the third plus 3x squared minus 6x minus 7. There are a couple of things that you do need to remember as you're doing synthetic division. If you recall, when we were doing long division, and I were to have, say, x to the third minus 1 divided by x minus 1, we had to have our exponents decrease by exactly 1 each time. Notice in this case we go from 3 down to 0. When you do synthetic division, you also have to put those zeros in. So again, in the box, we're putting a positive 1 this time, since we have negative 1 in our quantity. Writing out x to the third minus 1, our coefficients are 1. We have 0 x squared, 0 x's, and a negative 1. If you think about x to the third minus 1, you could write this as x to the third plus 0 x squared plus 0 x minus 1. So that's where your 1, 0, 0, negative 1 come from. And the process now becomes the same. Bring down your 1. 1 times 1 gives you 1. 0 plus 1 gives you 1. 1 times 1 is 1 again. 0 plus 1 is 1. 1 times 1 is 1. Negative 1 times 1 is 0. So here's our remainder. Again, our constant term. Our linear term, since it's positive, we put a plus. Our quadratic term, and again a plus because it's positive. So our final answer is x squared plus x plus 1. So we can say that x minus 1 is a factor of x to the third minus 1. And there's your answer. Now, another useful reason that we look at synthetic division is called the remainder theorem. The remainder theorem is a nice way of being able to find the value of a function. Let's say I give you the function f of x equals 2x to the third plus 3x squared minus 4x plus 2. And I were to ask you to find f of negative 2. Well, in order to do that, we replace the negative 2 for all of our x values. So we have 2 times negative 2 to the third plus 3 times negative 2 squared minus 4 times negative 2 plus 2. Working this out, we have 2, negative 2 to the third is negative 8, plus negative 2 squared, 3 times 4, plus 8, plus 2. Continuing, 2 times negative 8, we have negative 16. 3 times 4, we have 12. And then 8 and 2 gives us 10. And finally, negative 16 plus 12 plus 10 is a positive 6. Now, instead of doing all of this work, what we can do is take this value that we're looking for, negative 2, place it in our box, and bring down each of our coefficients, 2, 3, negative 4, and 2. Using our synthetic division, we bring down our 2. 2 times negative 2 gives us negative 4. 3 and negative 4 gives us negative 1. Negative 2 times negative 1 is 2. Negative 4 plus 2, negative 2. Negative 2 times negative 2 gives us 4. 2 plus 4 and 6. Hey, hey, hey. If you notice, those two answers are the same. So instead of doing all of this work, a little synthetic division gives us the answer. So we can say f of negative 2 equals 6. And there's your answer.